There are two existing schools of thought. One existing school of thought is based on kind of traditional older robotic frameworks, which says that the robot is going to be constrained by physical barriers, like fences and so forth.
In
And
a industrial setting or warehouse setting, where it is already, lanes are already set, right? Like,
correct,
yeah.
correct. Lanes could be set, but now with autonomy, lanes could not be set. But the whole idea is that the system is generally inherently stable because it's on wheels or it's latched
Mm.
down and it doesn't move around, but you're going to keep it away from people. And as a last resort, you have a emergency stop button. You hit the
Mm.
red button and it stops, and that's good enough. So that's one school of thought. But notice the constraint that I had to put in there. There's a lot of stability. There are a lot of
Mm.
barriers. There's a second school of thought, which is now we have robots roaming and free autonomously. And as long as the autonomy layer is good enough, then safety is built in. So by becoming multiple nines reliable, the system will then behave in a safe manner. That may be statistically true, but it's not guaranteed to be true.
Yeah. So like in self-driving, you're talking, or a humanoid suddenly uh, failing unpredictably, falling over. You need to respond in milliseconds, and failure is guaranteed. In the real world, you want to have it fail safely. That's
Correct. Yeah. So, the autonomy, if I can sum up the autonomy approach to safety, is practice makes perfect. That if I learn enough, I'll just become safer and safer. And there are two different standards for in the factory. We have a zero failure policy that we don't want any accidents. Uh, in the real world with cars, we tolerate deaths and accidents. So that approach may work well if the regulatory system says, okay, a few accidents here and there are okay, and insurance policies are going to cover for that. Regulatorily, it does not work inside the factory because you have to have a zero failure scenario. And if you are retooling factories with autonomous systems, which is going to be advantageous, they're faster, more nimble, they create better scale, you want to have a safety policy that gives you that guarantee and gives you the ability to meet regulatory requirements, yet have the smarts of an autonomous system. This is not to say that three laws is not applicable to autonomous cars. It just says that it can bridge the gap between full autonomy, take advantage of that, basically let your autonomy layer run loose, yet have a layer of deterministic behavior between the autonomy layer and the controller so that the system always adheres to policies and makes sure that the system's stable and safe.
Yeah.